This presentation is a very brief overview of several theories of learning and instruction, and more specifically focuses on Gagné's domains of learning. There are many theories of learning and instruction. This is a broad field of study, and we have entire courses devoted to this subject. So this presentation will not attempt to cover this entire field and is only presented as a means of helping instructional designers to begin to categorize goals during instructional analysis. The purpose of this presentation is to teach the viewer how to categorize goals and problem subcomponents during instructional analysis. To accomplish this task, this presentation provides an overview of learning and instructional theories. It discusses three classical frameworks that will provide some guidance to the learner, and finally, it turns its focus on Gagné's domains of learning. As an instructional designer, you'll need to learn how to classify problem goals and subcomponents. A way to do this is to use Gagné's framework, for it serves as a taxonomy of learning. Gagné took a scientific perspective of learning to consider how instruction could be broken down into its component parts. This idea led Gagné to organize instructional materials into diagrams like the one you see here. He called this type of diagram a learning hierarchy. This presentation discusses the theory that underlies this framework, and learning hierarchies are composed of many parts, as you'll see. But before you'll be able to produce diagrams like these, you'll need to understand the underlying components of Gagné's framework. So let's begin by considering the relationship between learning and instructional theories. This diagram shows the relationship between learning and instructional theories. In short, instructional theories explain how instructional methods promote learning outcomes. Gagné's theory is at the heart of this diagram, for his theory was based on the idea that educators should promote the required conditions for learning. And once these conditions were met, that would help learners with a favorable learning environment. This environment encourages learners to learn. An important note here though, guidance and feedback is helpful, for it helps learners to be able to attain those learning outcomes. As you're aware, an instructional designer's role here is to help those learners to learn. To do so, they provide instruction via instructional methods. Instructional designers also use learning theories to explain how the conditions provided promote learning. Therefore, instructional designers accomplish the goal of encouraging learners to attain learning outcomes by using instructional theories, learning theories, and evidence-based practice to help learners to learn. Again, there are many different types of learning and instructional theories that describe how best to design instruction. Let's take a look at a couple. Let's begin our discussion of learning by considering three theoretical frameworks. These theories are classics from instructional psychology and instructional design. They build on each other and will be described here in a way that will help you understand the nature of learning. First, we consider Anderson's theoretical framework, ACT-R. Then we will turn to the work of Benjamin Bloom, who developed something called Bloom's taxonomy. Finally, we will consider Gagné's domains of learning. Each of these frameworks have strong acceptance in the field of instructional design and will be the basis for our design methodology. John Anderson developed the ACT framework. This is a simplified version of his model, but it's been the basis of cognitive psychology for several decades. The ACT framework considers several types of learning and memory. You may remember working memory from your introductory psychology courses. Working memory is a constraint on the human nervous system and controls how we interact with the world. This model also describes two types of learning and memory, procedural and declarative learning. Declarative learning is concerned with the learning of language-based information like facts and events, as opposed to procedural learning, which is more skills-based. If something requires you to learn how to do something, then that's procedural learning. An example of procedural learning is learning how to dance or how to use a computer program. These are both skills-based procedural forms of learning requiring practice to attain expertise. Key words here are how to. Typically when you use the words how to, it's procedural learning. Declarative learning is a little different. You're engaged in declarative learning right now. You're trying to relate words and phrases to other words in order to understand the meaning of this presentation. These are two different types of learning or learning goals and will require two different types of instruction. One way to think about these forms of instruction is to describe them as inform or perform. Teaching the learner about something is to inform them, and this is often taught via an explanation like this one, as opposed to teaching them how to do something or perform, and this is often taught via a demonstration. Now let's move forward to another theoretical framework which builds upon the ACT-R framework. Bloom's taxonomy has three domains of learning. His terminology is a little different, and he describes these forms of learning as the cognitive, psychomotor, and affective domains. And these are sometimes referred to as knowledge, skills, or attitudes, or just KSAs for short. And even though the terminology is a little different, now declarative or verbal learning is represented here by the cognitive domain, and procedural learning is represented here as the psychomotor domain. And these are not too different than what we've just discussed. However, Bloom's taxonomy adds a third learning domain called the affective domain. Bloom knew that although someone may know how to do something, their attitudes towards certain behaviors control their actions. So as an example, people know that they are supposed to stop at a red light, but sometimes they choose not to. Let's use this red light here to classify these learning goals again. And let's begin with the affective domain. When the learner consistently chooses to stop at a red light, they may be said to have attained an affective learning goal. This is opposed to, say, learning how to steer a car, which is a psychomotor goal, because it's a skill and it requires physical movement and practice. Now finally, if we wanted the learner to describe the meaning of, say, the yellow light, that would be a cognitive goal because it requires verbal or declarative explanations from the learner. Okay, now let's take it a step further and go to Gagné's domains of learning. Gagné's domains of learning were developed after Bloom's taxonomy, and Gagné really built on Bloom's work, so some of these ideas may seem familiar to you. The first three here are really just an expansion of Bloom's cognitive domain. Psychomotor skills are what we just discussed a moment ago. They're skills-based or procedural in nature, so they require physical movement and practice. What Bloom describes as the affective domain, Gagné renamed it slightly to call it attitudes. So Gagné's real advancement was to further subdivide the cognitive domain. Since we've already looked at psychomotor skills and attitudes, let's look at the first three there: verbal information, cognitive strategies, and intellectual skills. The first of these is verbal information. Verbal information is the simplest verbal information possible. It's simply the recall of a fact. There is no symbolic manipulation, no rules being applied, no problem solving. So in essence, these goals simply require learners to provide a response to a specific question. So from a behaviorist perspective, this is a response to a question stimulus. Here, for example, what is the capital of Hawaii? The answer is Honolulu. Okay, cognitive strategies are a step up from verbal information, but it's still a simple learning goal. Cognitive strategies are memory control processes. These processes help learners to learn simple ways of attending to, remembering, learning, or thinking about information in some way. An example cognitive strategy is the mnemonic device for learning the colors of the rainbow, Roy G. Biv, or red, orange, yellow, blue, indigo, and violet. Cognitive strategies can also be rehearsal strategies like repetition or backwards chaining. Simple strategies like these can help one remember facts, but the use of these strategies is kind of rare. Next is Gagne's intellectual skills domain. Gagne subdivides intellectual skills into 4 types. These are making discriminations, forming concepts, applying rules, and problem solving. These 4 intellectual skills build upon one another, and we will look at these individually. So let's start with the simplest of these, discrimination. Making discriminations means that you are able to tell one thing from another. You can tell that there is something different about these shapes. That's discrimination. Next in the intellectual skills domains is concepts. In some versions of Gagne's taxonomy, he differentiates between concrete concepts and defined concepts. A concrete concept is a concrete object and is something you can point to. Here are some examples: boat, star, mammal, etc. These are all concrete concepts. On the other hand, we have a defined concept, which is something that cannot be identified by pointing to it. Some examples of these are integrity, credit, love, those kinds of things. To demonstrate an understanding of a concept, the learner would have to describe an example and explain why it's an example of that concept. It's not enough to simply state the definition of the concept. Providing examples is a useful instructional tool also, for it helps you to teach concepts. However, real examples can be cumbersome or hard to come by. A cow, for instance, is not easy to show most audiences. Therefore, the designer can use media to describe examples. A picture is a convenient substitute for the real thing, in other words. Pictures allow the designer to explain the attributes of the concept. In this case, the cow is a mammal because it has attributes like mammary glands, hair, warm-blooded, and has live birth. But remember, not all concepts are tangible objects and may not be represented by graphics. When describing concepts, it's often helpful to show non-examples to help reinforce a definition and explain the attributes of an example. So for a mammal, one might use a dinosaur as a non-example because it does not have mammary glands, hair, warm-blooded, or have live birth. Okay, the next item within intellectual skills is rules, or really rule application. Rules describe the conditions under which behaviors occur. The learner should really demonstrate the application of that rule, though. To assess rule application, learners should be observed over a period of time to determine if a pattern of behavior is observed. In other words, observe a learner to see if they're actually following the rule. It's not enough to state the rule. That's just verbal information. One must actually demonstrate the use of the rule. As an example, let's consider a driving test. These tests are usually conducted through pre-specified routes, which require the learner to react under normal driving conditions and actually follow the rules of the road. Finally, we have the problem-solving level. This is the highest level in Gagné's intellectual skills category. According to Gagné, problem solving is higher order rule application. That it is the use of two or more subordinate rules in order to solve a problem. As Gagné describes it, there is an infinite variety of problems, and certainly many of these have their own unique solutions. However, there are underlying principles which guide the development of problem-solving instruction. One of these is that learning is promoted when learners actually observe the demonstration of problem-solving skills. In the Tower of Hanoi puzzle shown here, it would be much easier to solve the problem if the solution was demonstrated to you first. Still, this puzzle is somewhat difficult, so learning is also promoted when learners actually practice their newly acquired problem-solving skills. So again, even though you've seen the solution and you know how to solve the puzzle, it's important for you to solve it for yourself. And it may take some practice to become proficient. A common instructional approach is to use the rhyme, show me, watch me, let me try. That is, demonstration first, then provide some practice with guidance and feedback. And finally, it's often necessary to require learners to synthesize and reflect on what they've learned. Therefore, when considering problem-solving instruction, instructional designers should promote learning by using a task-centered approach. That is, they should begin with a demonstration and follow up with practice of the component subskills. Okay, that's it. These are all the levels and types of learning that Gagné described in his domains of learning taxonomy. We looked at verbal information, that is a simple verbal response to a question like the capital of Hawaii is Honolulu. We considered cognitive strategies, which includes mnemonics like Roy G. Biv. We also considered psychomotor skills like learning how to dance or how to use a computer program. We discussed attitudinal instruction like choosing to obey traffic signals. Finally, we also just finished discussing the 4 levels of intellectual skills. Again, the 4 levels of intellectual skills are discrimination, concepts, rules, and problem solving. The reason for this long list of learning domains is to prepare you for goal analysis during instructional analysis. More about that in another presentation. After categorizing goals, you can consider subordinate skills or subtasks within a larger problem-solving goal. Again, this diagram is what Gagné called a learning hierarchy. Each of these learning domains may be then organized in a hierarchical analysis. By now you should have the terminology at hand and have the prerequisite knowledge to begin the process of producing such a diagram. We'll take a closer look at developing these diagrams and in another presentation begin the process of organizing subcomponents during a hierarchical analysis. Finally, this presentation was somewhat complex, and you may want to pause and replay portions of this presentation if you feel you missed something. Hopefully it has shown you how to analyze a problem and categorize problem subcomponents. Thank you very much. Goodbye.